So that we know the distance it's traveling is 21 meters, so I'm going to write that down. And it says here it's going at constant speed of 2.4 meters per second. So this means that it's not accelerating, but it's merely just has a constant speed of 2.4 meters per second. And these are the only variables we need. We can just use the equation of velocity equals distance over time. And then let's solve this to figure out time. So vt equals d, and so t would equal d over v. And if we plug that in, so t equals 21 meters over 2.4 meters per second, we should get 8.75 seconds. Alright, so the next part, we need to find, we need to draw and label a free body diagram for the sled as it slides down. So, we know, since the sled is at an angle, the normal force is going to be the sled this way. So here's the force normal. And then gravity is always going down. So gravity is always going down this way, no matter where you are. So this is the force of gravity. And in order to find, we gotta, since the normal force is going against the slope, parallel to the slope, perpendicular to the slope, we have to divide the force of gravity into its x and y components. So this would be F, G, Y, and this will be F, G, X. And then we also have friction as it slides down. So let's draw a little thing, friction right here. So force of friction. I had a bit of problem with friction, but if you draw out the free body diagram, it makes it more clear. We see here that friction is going this way. The force of friction is going this way. And what we can do is we can set it equal to the y component force of gravity, this going this way. So what I'm going to do is first I'm going to use the sum of forces equation, so that equals mass times acceleration. And we know that acceleration is 0, so we can just get rid of this side. So the force of gravity, this should be x, force of gravity x minus the force of friction. Because, of course, the cart is going down this way, and then friction is pulling it back this way. And that equals 0. So the force of friction simply equals F of gx. Now, I had a bit of problem figuring out F of gx on the test, but it's easier if you draw out a separate diagram. So we know here is 15 degrees, and we want to find this right here. If we draw a triangle here, we want to find out this. So this gx. So if this is 15, you have to imagine a triangle got flipped, which means this angle right here would also be 15. So if we know this angle is 15, the FG of x, which is on the other side, opposite side of the triangle, so we would have to use sine. So we have mass, gravity, and then sine theta. And so we already know all these numbers, so we can just plug it in. So force of friction equals the mass of this is 25 kg, but we need it in grams. So I'm gonna say 200 Okay, so now we just simply plug in all our variables. So FFR equals force of friction equals mass, which we have is 25. Gravity is always 9.8 meters per second. And the sine and the angle they give us is 15. So I'm going to plug this all in to my calculator. And we get 63.4. And since it's force, we have to use the correct measurement, and that would be in newtons. Okay, now we need to find the coefficient of friction. And I wrote down the force equation here. And I think in order to find the coefficient of friction, we also need the equation for that, which would be friction equals the coefficient times the normal force. Now, you need to find the normal force. So what I'm going to do is I'm going to come back here and find the normal force. So force and normal minus, since it's here, we got to look at what is directly opposite that. It was just kind of what I had a bit of trouble on the test. But since we clearly see that is g of y, force of g of y, and that equals mass times acceleration. And we already know the acceleration is 0, so we can just x that part out. So normal force equals f of g of y. And we're going to do the same thing we did as part C, except we're going to replace f of g of y with mg cosine theta, since it is adjacent to the angle. And if we plug all the numbers in, it would give us 25, 9.8, cosine theta, cosine 15, and that would give us 236.7 newtons, approximately. So, in order to find the coefficient of friction, let's rewrite this equation. So it would be force of friction over the normal force. And if we plug everything in, we got force of friction over here, so 63.4 newtons over 236.7 newtons. You will get 0.27, and then that is your coefficient.